that. Very easy. Here you have whatever eyepiece you choose to put in. I have a 6.5mm Plossl eyepiece. This one says it's fully coated. Normally you can see the color hues of the coated optics on the lens here, but for this one you can't. So either I'm presuming it's just worded like it's coated optics, or it's actually coated. Anyway, one or the other. It's a pretty good eyepiece. I've tried it before on my little refractor, and it seems fairly good, especially for views of the moon. So now we starting off, you can either decide to use your eyepiece. So you just pop it in here, and you twist the little knob on the side to secure it in place. And all you then have to do is make sure you take your cap off, because a lot of the times, you can forget. I do that. You take the cap off, adjust the telescope to the object that you want to view, and just simply look through the focuser. And it's very convenient. Also, you have adjustable legs here that you can put it up or put it down, and it's pretty good. Now, let's move on to the mirror. I don't know if you can see that there. I hope you can. Let me see. Move it. Yeah, there it is. Here is the mirror. Now, a difference between a refracting telescope and a reflecting telescope. Let me just adjust this because it's kind of moving. Yeah, just there. The difference between a refractor and a reflector is a refracting telescope is based off Galileo's original design. So the popular misconception is that he was the one that originally invented the telescope, which is not the case. The telescope, I believe, if I am not mistaken, was invented a year prior by another individual, which I don't recall his name. Anyway, Galileo heard about the telescope, and he heard about what was originally known then as a spyglass, which consisted of an objective lens in the front. So when we say objective, we refer to the main lens, or the main diameter of, or the aperture of the front, the objective, and the back, like I was talking about with the little refractor here. So picture this, but in a bigger scale. That's what it is. So we now know this as refractors, or you can sometimes refer to them as Galilean telescopes. So it has a convex lens at the front. If I do remember correctly, it has a convex lens at the front, which is slightly curved, curved, and at the back it has what we call a concave lens. So this is I think flat, if I'm not mistaken, right? Correct me if I'm wrong. So the objective of the refracting telescope is it sucks in the light from the objective, goes right to the end of the tube, and the light scatters, opens up and scatters, and enters your eye from the eyepiece. Now, what's happening with refractors is that when the light reaches the end of the tube, what can happen is what we call color aberration. So what that is, the light scatters, and therefore the image that you're viewing, say Saturn or the moon, has either a blue rim around it, or Venus, for example. All the light is scattered in different areas. So the image that you're viewing is not very clear, and it's just the hues and color is all over the place. So it's not really convenient. So that's the downside of a refracting telescope. Now with a reflector such as this, and reflectors of larger apertures and focal lengths, respectively, these are commonly known as light buckets. These instruments are capable of absorbing a hell of a lot of light, and So you say, for example, you're viewing Mars, let's say, or let's say the moon. The moon is a good object. Let's say you're viewing the moon, right? So the light from the moon comes through the objective here, which in this case is the mirror at the end. So remember, we don't have a lens at the front, we have a mirror. That's the difference with reflectors. Refractors have lenses, reflectors have mirrors. So if the light comes down the tube, hits the primary mirror, then shoots back up, and it hits the secondary mirror, which is at the front here, and then that light gets directed into the focuser, out through the eyepiece to your eye. And the light, the whole aspect of a reflector is the light hitting the primary, coming up through the secondary, and coming out, it comes to a focus. And therefore, color aberration is no more. So there is no more a problem with regards to color aberration because of the invention of the reflecting telescope by Isaac Newton, and that was a fantastic feat. So that is really the simplistic explanation of what a reflecting telescope is really all about. So when you hear about a reflecting telescope, you will remember that the light passes down the tube, hits the primary mirror, which is the mirror at the back here, hits the secondary mirror, comes up the tube, hits the secondary mirror, and comes out the focuser through and the eyepiece. So this is where your light is focused, and this is where you get a nice, clear, crisp image of the object you're viewing, whether it be the moon or the planets. Now, there are different sizes of reflectors. This one is a fairly small one. This is only 114 millimeters in diameter, the objective, and the focal is 900 millimeters. This is actually quite a good scope if you're not, let's say, if you're primarily using it for the planets and the moon, it's pretty good, you know. If you want to do stuff more like locating galaxies and star clusters, then you want to consider getting something at a fair bigger scale. If you consider saving up a bit, looking at a sky watcher perhaps. These instruments, they sell for reasonable price. When I say reasonable price, when you compare them to Orion's instruments, the prices are quite distant. So, for example, if you want to consider viewing galaxies and star clusters, I would recommend 8-inch and above. If you're viewing through an 8-inch instrument, then you most likely will find that if you're staring at the Orion Nebula, for example, you will see that it doesn't appear in color. It's more of a black and white. This is because this is deep sky object. This is serious business. You know, it's deep space. But once you enter the 10-inch, 12-inch, 14, 18-inch, then the whole space kind of opens up to you. It's really incredible. I personally haven't observed through a larger telescope as such, but from the videos I've seen, it's quite incredible. So that's it. Yeah. What else can I tell you? Yeah. So the 8-inch sky watcher, for example, that gives you a huge diameter of 203 millimeters and a 1,200 millimeter focal length. The 10-inch, I think, is about 300 millimeters, if I'm not mistaken, or maybe it's the 12 or 10-inch. Anyway, one of those two. 300 millimeter diameter, 1,500 millimeter focal length. So already, even in that small numberings, what I just mentioned, you can see that it's quite a difference in what you can observe in the night sky. Yeah, but this is quite a good little telescope. I've had it for many years. I've only recently had a sparked interest in astronomy. Like I've always had sort of like an interest in space per se, but it wasn't something as much. You know, like there was a little spark there. You know, always. But this is a good place to start for astronomy. So that's a basic understanding of reflectors and a bit of refractors, and I hope I've helped you somewhat in if you're deciding to get a telescope and seeing the differences between. Don't just rush to get a telescope. you know, you must do your research first. You know, I hope I've provided some research. Also, speak a bit about Dobsonians. Dobsonians were originally coined down by John Dobson in the 1970s, I believe. He was originally a Buddhist monk, and what happened was one night he was observing the moon through his telescope, and he said, "My God, you know, everyone's got to see this, you know, the moon." So that prompted him to start a group called Sidewalk Astronomers. Now these people are all over the world. So, and he's also the creator of what we call the Dobson mount. So instead of having a tripod, it has like a, I'll have to try and post a picture of it. It has like a, it's a stand basically, and you just put the optical tube in, and you can just adjust it back and forth. Now, the only downside to it is that these can become quite heavy the larger telescope you go. So I would recommend the 8-inch at the most if you're slim built, pretty much like me, or you know, just can't, you know, you're worried that you can't carry too much because you might get a hernia or something. Yeah, the 8-inch is pretty good. Any larger than that, then you might have some problems. But yeah, it's all about your taste and what you can afford, obviously, and what you're willing to do. So yeah, that's it. That's really all I really wanted to say. I hope this review of the reflecting telescope has helped you, and yeah, I'm actually quite surprised. I normally get quite a bit anxious in front of a camera, so I hope that look, I just hope this tutorial has been helpful to you, and yeah, that's an overview of my reflecting telescope. So clear skies, and I will try and